This is page 224 in our notebook. It's corresponding to section 2 in chapter 8, but it really just has to do with kind of introducing us to the coordinate plane, goes back over graphing. If we were looking at the coordinate plane, we would have quadrants that we could talk about as well. We have two axes like this, and so we have our x variable right here and our y variable here. The positive numbers go up this way and the positive numbers go this way. And so this would be like, say, 1, 2, and 3. And this would be 1, 2, and 3 as well. But over here, you start getting negative numbers like -1, -2, -3 in the x direction. Okay, and then this would be negative, negative, and negative. Now, my spacing on there is a little bit off. Hopefully, we just give you a graph to be able to work with most of the time, so you don't have to make your own graphs all the time. That is too time consuming. The other thing we're talking about is not only an introduction to and a review of graphing in the coordinate plane, but also being able to talk about the word congruent. Congruent means that they're not only equal to in length, but they're also the same shape. For line segments, they're pretty much the same shape. It's like a line segment. But in order for them to be congruent, they must have the same object and the same length. So two things must be true about it. The length of AB. Notice the terminology here. The terminology is this is AB is equal to CD. Well, we use these little hash marks, right, like this. And so this mark on there, right like that and right like that, means that they are congruent or equal in length. If there's that little mark on there, right like that, that's what that means. If there is not a line above it, see how this one has a line above it? That's talking about the shape AB, or the line segment AB is congruent to, see, this is congruent to CD because it's not only talking about how long it is, the length of it, but it's also talking about what is AB even. What is that talking about? It's line segment AB is the same size, the same shape, and it's exactly the same as CD, and that's what congruent is talking about. All right, because in the future, you could have like a triangle, and that triangle is congruent to this one if they're the same shape and the same size, which means that they're completely identical. So right here, AB, this is actually the way we would say this is we would say the measurement from A to B is equal to the measurement from C to D. So that means something a little bit different. It's talking about the length. This is talking about the line segment. So slight, tiny little difference on the language that we use. All right, let's scroll down. There's one more thing down below. This is called the segment addition postulate. It's just a really fancy and crazy way of displaying something that's actually really not that complex. If I have like a line that, let's see if we can get a straight line going right like this. Here's an example. If I'm going from A to, like, say, C, right like this, A to C, and I know this is 7 units and this is 4 units from here to here. So like in between these 2 points, and let's call this B. All right. Then what is the measurement from A to C? And notice I didn't put a line segment above it or any geometric notation on it. This just says from A to C, how far is it? Well, if I use the symbol equal to, that's saying what's the measurement of A to C, and that's 7 plus 4. So 7 plus 4 would be 11 in this case. And so that's all this is really saying, is that the two individual pieces add up to the total piece as long as each of these line segments add up to the total of the other one. Then the measurements actually correspond to adding up. It's really just kind of a overly complicated statement that really means something really simple, like the measurements of these two will add together. Okay, keep working through each of these. Watch each of my examples on the next page, and then the answer key is located down below.